here we will see two examples about use of the lens formula. And firstly, we will also draw the ray diagram first, so you can compare the results. Okay, so we use a very standard way to draw the object and the focal length, and then we will use our construction method. Okay, we will use the rule number 3, okay, to draw the light pointing to the center, and then the rule number 1 that the light goes parallel with the axis, and then we can find the position of the image using the ray diagram. Okay, so we can find the virtual image here, which is also magnified. Okay, and the position, the image is 30 cm away from the lens, and on which side? Okay, we will say that it is on the same side as the object. Okay, won't say left or right. Okay, because it's not accurate enough. And for the magnification is V over U. So it's 30 over 10. Okay, so it is equal to 3. And then we will try to use the lens formula again. So the lens formula is the 1 over U, okay, plus 1 over V equals to 1 over F. And for the U, it is given, it is 10, and the F is 15. So we can find the V, okay, by solving the equation, which is negative 30. So negative 30 cm, okay, why it should be negative? Okay, you can refer to the table and also the diagram. We'll find that it is a virtual image. So that's why the V is a negative value. So when you see the V is a negative value, because virtual image must be on the same size of the object, so we can get the completely same conclusion. And then for the m equal to v over u, so we just substitute the positive number is enough because it's just the ratio. Okay, and then because we know that it is virtual, so we know that it is also erect. And by calculating the magnification, we also know that it is magnified. And for the example 2, similarly, this time we have the object and the image already. So firstly, we will draw the position of the lens by using this way. Okay, so we can use the rule of 3, we can correctly locate the position of the lens. Why do we know it is a convex lens? Because you can see we have a real image here, so we can conclude that it is a convex lens. And by using the graph, we can also find the U and V at the same time. Okay, so we can find the focal length by two ways. Way number 1 is using drawing. So we will use the drawing to find the position of the focal length first. Okay, so from the figure, we know that the focal length of this lens is 19 cm. And then we can try to use the lens formula to find it more accurately. So by using the lens formula, okay, by substitute the U and V and solving the equation, we know that the F is really 19.0 cm. And we will continue with the part B. Okay, we will change it to another diagram. So, do you know what is the lens of this type? It's a concave lens because it is a virtual, erect, and diminished image which can only be formed by the concave lens. So we can find the U and V with the diagram here. And similarly, we will use two methods to find the focal length. Here is the graphical method. Okay, so we can roughly get the position of the focal length here. So from the figure, we know that the focal length of this lens is about 38 cm. And then we will try to use the lens formula again. And this time, 1 over f equal to 1 over u plus 1 over v. So why the v is negative 25? Because it is a virtual image, so make sure you substitute negative 25 so you can get the correct answer, which is negative 37.5 cm. Why should it be negative? Because this is a concave lens, so the focal length of the concave lens is negative when we use the lens formula.